Hello guys, I'm Vipin Kumar and today we do the Is Matter Around Us Pure, which is the second chapter of class 9th science. So firstly we talk about the pure substance and mixture. What are pure? What is the definition of pure? So the definition of the pure is every single particle that makes up the substance is identical. It means every single particle of that substance are identical and the same. So sugar particles, here take as an example of sugar particles considered to be pure substance. So what are mixture? Mixture that anything that can be separated by a physical process. So the physical process like filtration, winnowing, etc. So there are two type of mixture, homogeneous and heterogeneous. So homogeneous mixture, they are uniformly throughout. So like the example of homogeneous mixture is salt and water, and heterogeneous mixture not uniformly throughout like sand and water. So there are some examples. Brass is a type of homogeneous mixture. Air is a type of homogeneous mixture. Brass contains zinc and copper, and air contains nitrogen, oxygen, carbon dioxide, argon, helium, etc. And mixture of sand and water is a heterogeneous mixture. So what is pure substance? Anything that need a chemical process for separation. So anything that need a chemical process for separation, and that substance is called pure substance. So physical and chemical changes. So what are physical properties? Properties which are altered by physical process. And chemical properties are altered by the chemical process. So what is chemical process? Chemical process, when the transfer or sharing of electrons happen, that process called the chemical process. Like in this diagram, here the sharing of electron is happening. From electrons start from here and go here, then from here, and in this diagram the electron jumps from the one atom to another atom. It means that electron transfer from this atom to this atom. These are the electrons, these are the protons, and this is the shell. So digestion of food is an example of chemical change, because we eat anything, it become the glucose, which is C6 sorry C6 plus H12O6. This is the formula of glucose. So conversion of water into steam is a physical change. Like, so basically a chemical change is when the properties and the electronic and the chemical formula is changed, then it will be a chemical change. And when the state of a substance or change, and the properties of the substance is not changed, the formula is not changed, then it is a physical process change. Like in water into steam, the formula steam is just H2O, and the formula of water, normal water, is also H2O. So this is a physical change. Burning of wood and rusting of iron bar are example of chemical change. In these, the iron bar react with oxygen and make metallic oxide. So this is a chemical change. And burning of wood, in this all the properties and the formula is change of the wood, so it is also a chemical change. The solution and their concentration. What is a solution? A solution is a special type of homogeneous mixture composed of two or more substances. All solutions are mixture, but not all mixture are solution. It means that the all solution are homogeneous mixture. So all solution are mixture, but in the homogeneous mixture, in the mixtures there are heterogeneous mixture, type of heterogeneous mixture is also. So all solution is not a mixture, are not mixture. Now we do activity through which we understand the components. So take three beaker, one of them put salt and water, one other put some chalk powder, in third one put milk and water, pass a beam through the beakers. So what will we observe? From the first beaker, light passes and the path of light is not visible. And in the second beaker, the firstly it scatter the light. After some time, we left it undisturbed. The chalk powder settled down, and the upside of the chalk powder, the path of light is not visible. But if we pass the light through the chalk powder, then the light is not cross from the, and it scatter all the lights. And in the third beaker, the mixture of milk and water scatter the beam of light. So the mixture of milk and water scatter the light, and the path of the light beam is visible. The three main things a mixture to be a solution. So what are the things to a mixture be a solution? So it has to be homogeneous. The particle inside is really small, about 1 nanometer, which is equal to 10 raised to power minus 9 meter. And the path of light does not change. It means the path of light is the light beam is not reflected by the particles of the solution or mixture. So now we discuss what is solvent and what is solute. So solvent where solution is created, it means where the majority, which is in the majority. Like we take a beaker with 100 gram of water and dissolve 36 gram of NaCl, which is common salt. So in this, the 100 gram of water which is in majority, it is the solvent. And what is the solute? The substance which is mixed in or dissolved in the solvent. So the NaCl is the solute, which is less in number. So alloys. What are alloys? An alloy is a substance made by melting two or more elements together at least one of them metal. The components of alloy cannot be separated using a physical mean. So what is an alloy? An alloy is a substance which is made by melting and combining two or more elements. At least one of them be a metal. So these components means alloy. These alloys components cannot be separated by using the physical process or physical means. So concentration. Now again we understand concentration with a simple activity. So point number 1, take some copper sulfate, put it in some water. Take some amount of copper sulfate and take same amount of copper sulfate and put it in more amount of water, and then take same amount of copper sulfate and put it in the more than the amount of the second beaker. So what will we observe? So we observe that one of them more intense than the other. It means one of them is more blur or more bluish in the comparison to other. Or a word is also used that it is more concentrated than the other. It means the amount of solute is more in the first beaker than the two others. So saturated solution. What is saturated solution? It done. It or nothing more can be added to it. It means nothing. Thus, no more solute is added to the solvent. Now, it occur when the particles of a solution like water, we put some amount of salt in it dissolve, we again put some amount of it dissolve, but at a time the salt cannot be dissolved anymore. The at that time the solution is the saturated solution. Solubility. What is solubility? The amount of solute that can be dissolved in the solvent at a given temperature. So it means the amount of the solute or the capability of solvent to dissolve the solute in it at a given temperature. And solubility can be increasing by the increasing of temperature, and it can decreased by the decreasing of temperature. So how, if we increase the temperature, the kinetic energy of the particles are increased, then the interparticle space is more, so the more amount of solute can added to it. If the temperature decrease, the kinetic energy also decrease, so the interparticle space is less. So solubility of different substances is different. So like sugar and water solubility is different from the sugar and salt solubility. So we can represent concentration as the following. So amount of solute by the amount of solution. Mass of solute, if we find to concentration, mass of solute by the mass of solution. Mass, if the one value is given in mass and one is given in volumes, so mass of solute by the volume of solution. And mass of solute, if we find the percentage, so we can multiply it by the 100, like that. If we both the terms are given in the volume, so volume of solute by the volume of solution multiplied by 100, that give the concentration in the percentage of the solution. So now we do a question. So 36 gram of NaCl, 36 gram of NaCl, which is the common salt used in the home, and is dissolved in the 100 gram of water, which is H2O. So what is the concentration of it? So the temperature is given that 293 Kelvin or 298 Kelvin. It is a normal room temperature. So mass of the solute is this. The mass of the solute is 36 gram. Mass of solvent is 100 gram. So the mass of the solution is 136 gram. 100 plus 36, 136, and then we apply the method, which is amount of solute by the amount of mass of solution into 100. So we can reduce it and move to the simplest form and multiply it and then divide it, so we get the answer of 26.47%. So suspension and colloids. What is suspension? The suspension is this suspended particle in a mixture. If the mixture is left undisturbed, then the particles are settled down. So suspension basically the suspended particles which are in the mixture, and if the mixture is left undisturbed, then the particles are settled down. So what are colloids? Now we come to colloid. They have a special effect called Tyndall effect. So the colloid have a special effect called the Tyndall effect. What is a Tyndall effect? A Tyndall effect, the phenomenon in which light is scattered by the particle of a colloid. It's enabled a beam of light to become visible by illuminating particles, etc. It means what is Tyndall effect? is as you see in the dark room, the light is come from a single window, and there you can see that small particles are shine in the beam shine with the beam of light. That is that effect called the Tyndall effect. This name after scientist John Tyndall, whose lifetime is 1822 1893. So milk is an example of colloid. So here the comparison of suspension and colloid is given. So firstly, colloid are the particle of colloid are smaller than the particle of suspension. And colloids, they are stable, they do not settle down by the gravitational force. Particles are not visible with naked eyes because the size of particle is so small. They have the Tyndall effect. They cannot be separated by filtration. Means colloids cannot be separated by filtration. They have Tyndall effect. They cannot be seen by naked eye because they are really small. They are stable. They do not settle down as the suspension has, and the particles are smaller than the suspension. Now we come to suspension. Particles are larger than colloid and solution. They settle down with the gravitational force. Visible with naked eyes. They can be visible with naked eyes. They have no Tyndall effect partially. They can be separated by filtration. Now we combination of colloids. There are 6 types of combination of colloid: aerosol, foam, emulsion, sol, gel, and solid sol. So what is aerosol? Aerosol is the mixture of liquid inside a gas like cloud, mist, and smoke. Foam. What is the foam? Foam is the gas mixed inside the liquid like shaving foam. Emulsion is liquid into liquid. Liquid merge in the liquid, which as example milk. Sol means solid merge into the liquid like mud. An example is mud. Gel liquid in this liquid inside merge inside the solid. As example, jelly. Solid sol. A solid sol is, as the name suggests, the solid is mixed in the solid. As example, gemstone. Like that, in the gemstone, here a more solid gemstone here is also. So this is a colloid. So method of separation. What is the method of separation? So now firstly we have to know what is separation. Separation is a method that cover a mixture or solution into 2 or more distinct components. So what is a separation? Separation is a process in which the mixture and the components of mixture are separate, which is the component of mixture or solution into 2 or more distinct parts. It means if like the mixture of sand and water, so we can filter it, and its distinct component are separate. The sand is in the filter paper, and water is in which you filter the water. So immiscible and miscible. So we understand the immiscible and the miscible liquid by activity. Take a beaker, fill water in the beaker, put some oil in the beaker. So observe that. So if we let them stay for a while, the oil and the water is separated into 2 layers. In other words, the oil and water are immiscible like that. Like this, the oil and water is separated into two different layers. This is the oil, this is the water. So what is immiscible? Now we come to immiscible. What is immiscible? Immiscible is the property where two substances are not capable of combining to form a homogeneous mixture. So immiscibility is the property in which the two substances are not capable of combining as a solution. And like the example of oil and water, they are not capable of combining to form the homogeneous mixture or the solution. They form two different layers and they can separate it by the separating funnel. The separating funnel is like that. There is a tube and here is a knob, and from here is the open have to open or close. This is the knob, and there we put the mixture. In this we put the mixture of water and oil. So the oil is float on the water because the density of oil is less than the water. So oil is float on the water. When the complete oil is come upon the water, then open this funnel. When all the water is rising, then quickly close this funnel, and the oil is in present in this funnel, and the water is there. You store it. A mixture of kerosene and water can be separated by using the separating funnel. Kerosene and water mixture is also can be separated by the separating funnel. In a separating funnel, the immiscible liquid separate out in layers depending on their density. So in the case of the water and oil, the oil density is less, so the oil is float upon the water. So what is centrifugation? Now we come to centrifugation. Centrifugation is a technique in which involve the application of centrifugal force. What is centrifugal force? Like our gravitational force, it is centripetal, which attract things toward the center. Centrifugal force is attract the things outward. Attract the things. This is the center. So attract the things outward or distract the things outward the center at this direction. So capillarity. What is capillarity? Rise of a liquid in a small passage, such as tube of small cross section area, like the space between the fiber of towel. When we put any cloth in the water is quickly, but not quickly, but slowly rising up between the small space in the fiber of the cloth. So now we come to chromatography. What is chromatography? Chromatography is a technique used for the separation of solutes dissolved in the same solvent. So like dye and the blood components. Dye is separating from the water by the using of chromatography. Can be separated. The components of dye can be separated by the chromatography. The components from the bloods can also be separated from the chromatography. Now we come to distillation. What is distillation? Distillation process involving the conversion of a liquid into vapors that is subsequently condense back liquid form. So what is distillation? Distillation simply a process in which the two miscible liquids are mixed and and in their boiling point there are 25 degrees Celsius difference. So we can boil them and take the other from a tube to the beaker, and the other component which boiling point is high it will remain in the that flask in which you distill the solution. So now we come to fractional distillation. What is fractional distillation? Nitrogen is separated from air using this process. So we understand what is fractional distillation. Here is a diagram. You can understand what is the fractional distillation. From in the fractional distillation, the distillation chamber, different distillation chambers are made for the different things. Like here, how we get a pure oxygen from the atmospheric gas or atmospheric air. So this is the filter. This is the filter fitted here. From here, air go in, and these are the compressors. This compress the air, and now this air become the hot and compressed air, because if we compress anything, the kinetic energy is rise, and if the kinetic energy rise, it will be hot. So now goes from here, it goes to this chamber. In this chamber, the cold freezing water is passed, so it take all the heat from the air. So now it become the cold compressed air, and now it go to this separator in which the solid carbon dioxide or dry ice is separated, and from this separator it goes to here, and this is the jet expansion. From here, the nitrogen boil first, then argon, and then we get the pure oxygen. So now what is crystallization? We understand crystallization by activity. Take a highly concentrated solution of salt, cool it down and freeze it. What should happen? Observe. So observation: with the decreasing of temperature, the solubility is decreases, so some of that salt leaves the solution as a crystal. In the case the crystal of in the case of the crystal of salt, we get a really pure, but the only thing is that going to leave is salt. This process is called crystallization. So pure crystal of copper sulfate can be obtained by crystallization. So is water pure? You can understand it by how the water is come in our home tap, how it will be filtered. So firstly, it will reserve in a reservoir, then it go to the sedimentation tank in which the solid substance can settle down. From here it goes to the loading tank in which the sediment of suspension impurities are settled down, and then it goes to the filter in which the graves and other thing filter the water, and then it go to the chlorination tank in which all the bacteria are killed, and then it's come to our home. Elements and compounds. This is the last topic in our video. So what are elements and compounds? Robert Boyle in 1660 is the first scientist to use the term of element, but Lavoisier gave a proper definition of element. Robert Boyle only used the term element, but Lavoisier gave a proper definition. The definition given by Lavoisier is elements is something that cannot be broken down into simpler components even by using any chemical process, because the elements is of same type and they cannot be separated by the chemical process or the any physical process. So elements are divided into 3 states: metal, non-metal, and metalloids. So now we come to compound. What is a compound? A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. So like H2O. So in this like H2O, this is always combined in a fixed proportion. The two hydrogen atom is combined with the one oxygen atom. It is always you find that the water is always in this proportion. So now we discuss some differences in the mixture and compounds. So elements are or compounds just mix together to form a mixture, and no new compound is formed. It means the elements like elements or compounds like compound which is H2 and NaCl is mixed together to form a mixture, but they cannot react together. They only mix, they can separate it by a physical process. Compounds, the elements react to form the new components. A mixture has a variable composition. The compounds of each new substance is always fixed. It means in the mixture we can there is no ratio or the no proportion is defined. We can added any amount of the solute in the solvent, and but in the compounds the ratio is fixed always. Third point, a mixture show that the property of the constituent substance. The new substance has totally different properties. So in the mixture, which are the properties of the substance which are mixed to make this mixture is same. These properties are not changed, but in the compounds total properties are changed, because this is a new substance which is made from the chemical reaction. Fourth point, the constituent can be separated fairly easily by physical method. The constituents can be separated only by the chemical or electrochemical reactions. So this is our last topic. So if you like my video, please subscribe to our channel and tap to bell icon for taking my all the updates. Thank you. Have a nice day. Thanks for watching.